A lemon tastes sour, soap feels slippery, and your stomach makes acid every day. Acids and bases are all around us. In this chapter, we'll tell them apart with indicators, watch how they react, measure their strength on the pH scale, and meet the salts and everyday chemicals they make. Common salt, baking soda, washing soda, bleaching powder, and plaster of Paris. We start from scratch. First, how do we know if something is an acid or a base? We use indicators, substances that change color. Acids turn blue litmus red, bases turn red litmus blue. Methyl orange goes red in acid, yellow in base. Phenolphthalein stays colorless in acid but turns pink in base. There are even olfactory indicators like onion or vanilla whose smell changes with acids and bases. Acids taste sour, bases taste bitter and feel soapy. Now their reactions. An acid plus a metal gives a salt plus hydrogen gas, and that hydrogen gives a pop with a burning splint. An acid plus a metal carbonate or hydrogen carbonate gives a salt, water, and carbon dioxide, and the carbon dioxide turns lime water milky, the classic test. So fizzing with a carbonate is a quick sign of an acid. Bases react too. A base plus a non-metal oxide gives a salt and water, which tells us non-metal oxides are acidic in nature. And the big one, an acid plus a base gives a salt plus water. That's called neutralisation. The acid and base cancel each other out. Metal oxides react with acids the same way, so metal oxides are basic. What makes an acid an acid? In water, every acid produces hydrogen ions, H+, which join water as hydronium ions. Every base, if it dissolves, produces hydroxide ions, OH-. That's the real definition. It's also why dry hydrogen chloride won't turn litmus. Without water, there are no free H+ ions. Acids and bases that ionize fully are strong. Those that ionize only a little are weak. Mixing an acid with water is called dilution, and it releases a lot of heat. So always add acid to water slowly, never water to acid, or it can splash dangerously. To measure strength, we use the pH scale, running from 0 to 14. Below 7 is acidic, exactly 7 is neutral like pure water, and above 7 is basic. The lower the pH, the more hydrogen ions and the stronger the acid. pH rules everyday life. Tooth decay starts when the mouth's pH falls below 5.5, so we use mildly basic toothpaste. Plants and crops need a particular soil pH. Our stomach uses hydrochloric acid to digest food, and antacids, mild bases, relieve the excess. A bee or ant sting injects an acid soothed by baking soda. Nettle stings are acidic too. When an acid and a base neutralize, they make a salt. Salts come in families sharing an ion. All the chlorides, all the sulfates. The pH of a salt depends on its parents. A strong acid with a strong base gives a neutral salt like common salt. A strong acid with a weak base gives an acidic salt. And a weak acid with a strong base gives a basic salt. Common salt, sodium chloride, is the raw material for many chemicals. Pass electricity through its concentrated solution, brine, and you get the chlor-alkali process. It gives sodium hydroxide, chlorine gas, and hydrogen. React that chlorine with slaked lime, and you get bleaching powder, calcium oxychloride, used to bleach cloth and paper, and to disinfect water. 2 more from common salt. Baking soda, sodium hydrogen carbonate, is a mild base, an antacid, and with an acid like tartaric, it makes cakes rise. Heat and treat baking soda, and you get washing soda, sodium carbonate with 10 waters of crystallization used for cleaning and softening hard water. And plaster of Paris from gypsum sets into a hard solid with water, used for plaster casts. Those waters locked in a crystal are its water of crystallization. Quick check. The question's on screen. Pause if you like, but try it first. 10 seconds, go. Every acid in water produces hydrogen ions, H+. That single fact is what makes it an acid, so the answer is hydrogen ions, H+, option B. And that's the chapter. Indicators tell acids from bases. Acids and bases react and neutralize to form salts. Acids give H+ and bases give OH-. The pH scale measures strength from 0 to 14, and common salt is the source of sodium hydroxide, bleaching powder, baking soda, washing soda, and plaster of Paris. Free notes with 60 practice questions are in the description. Subscribe to Clarix and keep going.